Excellent. So thank you, Nico, especially for organizing everything. I'm not sure if you're aware, but Nico organized everything. Every single coffee cup here has been prepared by Nico. So thank you very much. My talk is about the quantified costs of climate change. Typically, when we think of climate change, we think, or at least the media thinks, about two things: the increase in the average temperature and the sea level rise. And that's what we talk all the time. That's what the COPs are always focused on. That's what, the COP, recently the COP in Sharm el-Sheikh was arguing about 1.5, and should we keep the 1.5 degree, or should we change it to 2 degrees, or whatever it is. Sea level rise is such a strong visual, that we always talk about sea level rise as well. And the way we meaning economists, and I apologize, I'm an economist, the way economists really typically talk about the cost of climate change is they use the integrated assessment models. What are the integrated assessment models? It's a model of the climate, a model of the economy, and an integration of the two. And that's an integrated assessment model. Typically, it uses a somewhat simplified model of the climate because, for various reasons. But it also uses typically a very simplified model of the economy, because the economy is incredibly difficult to model. And somewhat embarrassingly, the integration between the two is incredibly simplified. So this is just an example for the integration of the economic model and the climate model coming out of one of the most famous integrated assessment models. That's the IAM done by William Nordhaus, who won the Nobel Prize in economics a few years ago, largely for his work on climate change. And his integration of the economy and the climate is this equation at the bottom there, which basically says the damage from climate change, D, is alpha, which is alpha in his case is 0.00236 times the change in the average temperature squared. So the change right now, we are at the change in the average temperature relative to pre-industrial time is about 1.1 degrees. So it's just 0.00236 times 1.1 squared. We can all do that kind of calculation. That's as much as we go. That's the calculation in the integrated assessment model. Of course, there's some feedback that you need to account for from the climate to the economy, and the economy to the climate. But basically, that's the integration. So what I would like to argue is, first of all, that kind of framework is trying to look for the keys under the streetlight instead of looking for the keys where they actually are. And where the actual cost of climate change is not in the change in the average temperature, is in the change in the intensity and the frequency of extreme weather events. Okay? So we are thinking about flooding, and we're thinking about heat waves, and we're thinking about storms and droughts. That's where the cost of climate change lies, at least in the present, right? Maybe in the future, heaven forbid, we might have a 6 meter sea level rise, and then there will be a lot of costs associated with that. But at this point in time, the cost of climate change is not a change in the average temperature. It's not in the sea level rise. It's in those extreme weather events. Okay? And what do I mean by extreme weather events? Think of that. That's the most technical graph I'm going to put here today. So apologies for John. This is the precipitation on the x-axis and the probability on the y-axis. Basically, what climate change does is it shifts the distribution to the right. So here I'm colorblind, so I'm not sure what the colors are, but this is the kind of distribution we had before climate change, whatever color it is, and this is what we have because of climate change. So that curve is just shifting to the right. So you can think of this as either changing the frequency of extreme weather events. Those extreme weather events are becoming more frequent. That's just the vertical shift in the curve. Or you can think of it as the increasing intensity of these extreme weather events. That's the horizontal shift in the curve. right? So these are basically two ways to look at exactly the same phenomena. The curve is shifting to the right, okay? So the question is, can we use that insight that extreme weather events is the cost of climate change to say something about quantifying those costs, right? And for that, we can use something called attribution science. And attribution science, if I go back to this graph here, basically tries to either measure the horizontal distance here, that's the change in the intensity of the event, or it tries to measure the vertical shift here, that's the increasing frequency of an event, okay? And some attribution science projects do this, and some attribution science projects do that. And what I want to suggest is that we can use that to say something about economic costs, okay? And I'm going to give you two examples. One example is from Hurricane Harvey that hit the city of Houston in Texas in 2017. And in that project, we are looking at the changing intensity of the event. And in the other example I'm going to give you, I'm going to talk about a global assessment of the cost of climate change. And in that project, we're looking at the changing frequency of the event rather than the changing intensity of the event. So we're using both types of attribution science to say two different things about economic costs. Okay, the first paper, or the first project. We're looking at the flooding associated with Hurricane Harvey in the city of Houston. Hurricane Harvey was the second costliest hurricane in US history after Hurricane Katrina in 2005. So this is a very big event. This is not just some minor thing that washes a few houses. This project is a joint project with a bunch of people. These are much smarter people than I am because they are non-economists. There's a sociologist there, there's 2 climate scientists and 2 hydrological engineers. Okay, and we're looking at Hurricane Harvey. Hurricane Harvey was tremendously wet, one of the wettest we've ever seen from the standpoint of water. And that's an exact quote from someone who might become the President of the United States soon enough. One hopes not. If there's any American in the audience, please don't vote for him. But he's right, for a change. It was a very, very wet hurricane. Okay? And as I said already, it was the second costliest hurricane in US history. Actually, it was a Category 3 hurricane, so it's not a terribly strong hurricane. Using the categories that we use, so we categorize hurricanes Category 1 through 5. That's another example where we're looking for the keys under the streetlight rather than where they matter, where they are, because we categorize hurricanes using a metric that doesn't matter for their impact. The impact of hurricanes is almost always from the water. It's not for the wind, but we are categorizing them by the wind because scientists have an easier time measuring those. It's a poor choice, but we're doing that anyway. Anyway, what we're doing in this paper, so we're doing this attribution, we're using that attribution exercise on Hurricane Harvey, which I'm going to explain in a second, in as much as I know about it, and then match that with hydrological flood modeling for the city of Houston, and then using that with some socioeconomic data to say something about the distribution of climate change impacts in the city of Houston during Hurricane Harvey. Okay? So you can, as I said already, you can think of attribution as sort of 2 ways. You can think of the change in the frequency or the change in the intensity. Here we are focusing on the change of the intensity. And specifically, we sort of there are several papers that have looked at the changing intensity of that event. So how much more intense that event became because of climate change. So imagine a world in which Hurricane Harvey already happened, but without the amount of greenhouse gases that we've spewed into the atmosphere in the last 100 and something years. So that event would have happened, what would have been, there would have been less rain associated with it. Okay, how much less rain? 38% to be exact. Okay, Actually, the climate scientists are not that exact, but I'm just using an example here of 38% because that's the sort of the best estimate that we have. 38% of the rain from Hurricane Harvey was because of climate change. Okay? And then we can take that and use hydrological modeling, okay, to look at the flooding that happened in Hurricane Harvey as it actually did. That's the top left. And then subtract some rain from the rainfall that fell on the city of Houston during the hurricane and model what would have the flooding looked like in those sort of counterfactual cases. So here you have maps of two cases. One is sort of the minimum estimate that only 7% of the rain is because of climate change. And our preferred estimate, because we think it's the most robust, is 38%. Okay? Now, I'm told that this shows you that. I'm colorblind. I already warned you. And for some reason, they mapped red as flooded. That's what I was told. I don't know what to me, flooding makes more sense to model it as blue, but they did it the opposite. But I'm colorblind, so who knows? Anyway, the point is, of course, with 38% less rain, you will have less flooding. That's pretty obvious. But the point is you need the hydrological modeling because 38% less rain does not necessarily mean 38% less flooding in each location. That depends on how the flood actually works through the city, right? So in some cases, 38% less rain does not mean any less flooding, or in some region, other places, it could mean significantly less flooding, or maybe even no flooding at all. Okay, so that's why we need the hydrological modeling. And then what we do, we match that with socioeconomic data. So we collect socioeconomic data from various locations. We sort of obtain data on every single house in the city of Houston. That's a bit more than 1 million houses. And we know their value. We know what building type it is. We know the damage curves associated with those building types. We know something about the ownership of houses in the neighborhood, so not exactly the ownership of each house, but we can say something about the incomes in the very local sort of neighborhood, the incomes, the ethnic makeup of the neighborhood. You know, fortunately for our exercise, neighborhoods in the US are very segregated, so there is a significant change in the ethnic, yeah, sorry, but that's the way it is. If they were less segregated, we would have had a hard time identifying what we identify here. And then we match that with FEMA flood maps. So FEMA produces these 1-in-100-year flood maps. They're not really accurate, they're not really good, but that's not the point. The point is if you are in the FEMA 100-year flood maps, you need to buy flood insurance. And that's why we care about it, okay? Because it's much more likely that if you are within the FEMA flood zone, you will be insured for this kind of damage, okay? Not perfect, because a lot of people who are supposed to buy flood insurance don't. In the US, there's no monitoring of that. Like in New Zealand, when you take a home loan, you take a mortgage, the bank verifies that you have insurance for your house, but they never follow up to see if you reinsure it the following years, right? So banks here, in principle, if you're home-owned, in principle, you should have insurance, but in practice, the bank will, from the bank's perspective, you are mandated to have insurance, but actually the banks doesn't know if you have insurance or not. Don't tell anyone. But they don't. And it's the same in the US, which means that a lot of people don't have insurance, even though they're supposed to have insurance, even if they're in the FEMA flood zone. Anyway, if we look at the sort of the summary of the data, if you look at the 38% scenario, that's the column on the right. So even though the rain is only 38% of the overall rainfall was because of climate change, actually 50% of the properties that were flooded because of climate change. So of the 105,000 properties that were flooded during Hurricane Harvey, I warned you, it's a big flood, 50% of them were flooded because of climate change. So without climate change, they would not have flood. And if you look at the actual damage, it's even more than that. It's almost 60% of the damage is because of that 38% additional rain associated with climate change. Why is that? Well, first of all, you have 50% of the properties that were flooded because of climate change, but all these other 50% of the properties that were flooded, would have flooded anyway, they had additional damage because of climate change. Okay? So we end up with a calculation that says, well, 58% to be exact, 58% of the damages associated with flooding two residential homes in Houston was because of climate change. Okay? We are interested in the sort of the ethnic makeup of this. In this case, we found out that there seems to be sort of the storm was biased towards or against Hispanics, Latinx. So if you, about 40% of the population in Houston is Hispanic. And if you look at the population in those houses that were in the flood zone, so those are houses that were more likely to be insured. Roughly the same, that's the percent of each group. These are A, are houses that didn't flood. B are houses that flooded because of climate change. And C are houses that flooded, would have flooded anyway, but flooded more because of climate change, right? So if you look at the percent of houses which are owned by Hispanics, it's about the same for those in the flood zone, meaning insured. But for those that are uninsured, or likely to be uninsured, there's no prohibition on buying flood insurance if you are outside the flood zone, but people are very unlikely to do it. It's a significant difference because more than 50% of these houses are Hispanic. So there seems to be Hispanics that are uninsured seem to be more vulnerable to this. So if I can summarize what this sort of paper finds, and there's a lot more empirical things around that paper. I'm not going to talk about them. But basically, we find 4 things. Neighborhoods with more Hispanics had more climate change attributed flooding. Neighborhoods with higher incomes had more climate change attributed flooding. Why is that? Because higher income means they're on the waterfront or they're on the canal or something. It's nicer places, more amenities. But that relationship between income and the likelihood of flooding reverses for Hispanics. For Hispanics, it's the lower income Hispanics neighborhoods that are more likely to experience this climate change attributed flooding. And lastly, and maybe worst of all, it's not only the low-income Latinx neighborhoods, it's those low-income Hispanic neighborhoods that are outside the flood zone, therefore uninsured. Okay? They are the ones that are most likely to be hit by this climate change attributed flooding. Okay? So that's a paper that we already published, but we have some new results for another paper, which I'm sorry I'm reminding you of these 2 clowns again, but they're the ones who were responsible for FEMA at the time of the event. So we looked at the payments that were provided by FEMA to houses in Houston, and specifically look at the climate change part. So you can think of this as a compensation that FEMA provides to a household that has damage from the flood. Some share of that payment is because of climate change. Okay, and then we can calculate actually for each house how much of the payment that they received was because of climate change, and we can also sort of start slicing the data by income, by ethnicity, by things like that, right? So this is just one example because I don't have more than that because we're just working on this paper. This is just me and Kevin Smiley, who is a sociologist from Louisiana State. This looks, so there are 2 types of payments that they are providing in the US. There's the National Flood Insurance Program. That's the actual insurance that FEMA is providing for flooding, something that in New Zealand is provided by the private sector. And these additional individual assistance payments that they provide. Okay? The individual assistance payments are capped, so they're very limited in scope. I think they're capped at like $8,000. And survey data shows that a lot of people think that they're much more generous, and because of that, they don't buy insurance. Wrong choice, but that's what happens there. In any case, here I'm just showing you the distribution of these payments by income percentile. So the very poorest get nothing from FEMA, either in terms of insurance payments or individual assistance. And the very wealthy, the top sort of 5%, get a lot. I know it's terribly surprising that the US is unequal. I'm sorry to shock you. But if you're wealthy, you will get a lot more out of FEMA. That's maybe not a surprise that there's other papers that have reported that. But we've also looked at the share of the money that is associated with climate change, because we can calculate this with attribution. And I didn't really show you the figures, but the share is bigger. So the percentage of this figure, this is how much you get because of climate change, and this is how much you get, right? The share is bigger the higher the income is. Okay, the share of the payment from the federal government to these people that is associated with the climate change impact is bigger the higher the income is. Not to get too smug about this, we did a similar project a few years ago for EQC payments after the Canterbury earthquake, and they're also unequal, where the EQC was also paying more for the rich than it was for the poor. Again, as share of income, as share of the damage, as share of whatever you think you want to look at, there is an inequality there. It's less pronounced than here, but it's still present. Okay. So this is one example of what we could do with this kind of attribution research and sort of socioeconomic research. The other example I want to talk about is completely different scale. So going from the individual to the global. Okay, exactly the opposite. So what we're trying to do here is using the other type of attribution. That's the global, change in the likelihood rather than in the change in the frequency rather than the change in the intensity. I'm not going to bore you with the details of what that exactly is, but basically, trust me that when what the scientists are doing is they're basically calculating how much an event is becoming more likely. So say if an event that was 1 in 50 becomes 1 in 10, 1 in 50 years becomes 1 in 10 years, so a much more frequent event, then that basically means that 80% of the likelihood of the event is because of climate change. Okay? And we know that all of these events a lot of those types of events are becoming more likely because of climate change. Okay? So what do we do here? We do these, we look at those calculations of what is the changing frequency of extreme weather events in various places. And then we match that with global economic costs on extreme weather events using a global database called MDAT, which a few of you might be familiar with. And then we match the events. We match those events on sort of temporal and geographical scale. And then we say something, as you will see in a minute, we say something about the economic costs of these events. Okay? Now, once we've collected, so we've looked at 250 studies on attribution, collected all the data from 250 studies, and then we average them out, and we come up with this graph. Okay? So what does that graph mean? So for example, focus on heat waves on the left. Heat waves on average are becoming 77% more likely globally because of climate change. Okay? Or at least maybe qualify this because scientists like precise language, so I apologize. For all those heat wave events for which we have done this calculation, the average is 77% increase. Okay? Now, there is a range because some events, and that's where you see that one there, right? Some events are becoming 100% more likely, 100% of their likelihood is because of climate change, meaning without climate change, they would have been impossible. Okay? Or as the climate scientists like to say, virtually impossible. Okay? that was, one example of that was a heat wave, when was it, a year back? In the northwestern United States and sort of western Canada, sort of around Oregon, Washington, British Columbia. There was a heat wave event that was perceived to be, at least by the scientists, they said it was virtually impossible without climate change. Okay? So there is a range, and you can see, equally, you can see some heat wave events that are only maybe, I don't know, 20% more likely because of climate change. So there is some heterogeneity there, but basically the average is 77. You can see, for example, that, I know, surprise, cold events are becoming less likely because of climate change. Okay? So if you live in the North Pole, I think there's only one person lives there, right? The guy with the beard. Anyway, he's going to have warmer summers. So there is, and there is variation, right? So droughts are becoming more likely, but by less than heat waves. Floods there's actually quite a range in terms of flooding. So in some areas, flooding are becoming less likely. Some types of floods are becoming less likely. Some types of floods are becoming more likely. On average, globally, they're 20% more likely. Okay? And even within New Zealand, we would have nuances. So floods are becoming more likely in some locations, and floods are becoming less likely in other locations. Okay? And then what we do that, we match that with economic data, with the damage data, and then we can, for some reason there should be another bar on top of that, but you don't see it. This is the amount, I don't know why the colors don't work. So I have here in the graph, believe me, I have it. So imagine something sort of virtual here that looks at the total losses of extreme weather events as % of global GDP. And then at least the one you can see is that part of the overall losses that is attributable to climate change. Okay? So you can see only the climate change attributable part, but that's okay. Anyway, you came to hear about climate change, not about extreme weather events, right? So, so that's as share of global GDP. Of course, it fluctuates from year to year because in some years we have a big event, and in some years we don't have a big event, right? So in some years, the share of global GDP that is lost to climate change-induced extreme weather events is maybe only 0.06, but equally the previous year was much, much, much higher because there were some big events in 2008. Okay? One last point there. If you average that out, that amounts to $143 billion annually. Okay? You all think it's a big number. It's more than you have in your bank account. But it's a big number any way you look at it, right? The discussions in the COP have been in the past few years about that $100 billion that we've promised for mitigation and adaptation, okay, with only about 10% going to adaptation, so 90% to mitigation and 10% going to adaptation, $100 billion. But actually what I'm showing you here, that in the past 20 years, this is not going forward, this is right now. In the past 20 years, the average climate change footprint of extreme weather events was $143 billion. Okay? So we are vastly underestimating the amount of money, and this is actually especially relevant when we are now in the recent COP, we've just established this new loss and damage fund. We haven't established anything, we just promised that we will establish something, but without any money in it, my argument is we will need at least $143 billion in that fund to just match what we are already experiencing. So this is not going forward, this is just now. Okay? Okay. What the other thing we did with this, with exactly those calculations, these are the same numbers, sort of the dark bars, whatever color they are the numbers you have just seen in millions of dollars, not in % of global GDP. And then we compare that to what you remember I started with the standard way we look at the cost of climate change is from the integrated assessment models. So we are comparing the DICE numbers, the result from this Nordhaus integrated assessment model, to our numbers. Okay? So the little bars there are what the economic models say that the cost of climate change is. And our numbers is just for extreme weather events. Okay? These numbers are the cost that the integrated assessment model is estimating for extreme weather events and all other environmental impacts. Okay? Now, they don't distinguish between the two, so we can't break it, so we can't compare apples to apples. So we are comparing our apples to their apples and oranges. Okay? And still, our apples is much bigger, obviously. Okay? So what I'm trying to say with this slide is the integrated assessment models, in general, the economic assessment of the cost of climate change is vastly underestimated. Okay? Okay. One last thing I want to say. I have no idea how the time is. How are we with time? Okay, so perfect. So one last thing we're trying to do here. So I think you can see, and I hope I convinced you, that there is something powerful about this matching of attribution science with economic data to say something meaningful about the way that we are experiencing climate change. There's also, from a rhetorical perspective, that's potentially useful exercise, because you can then sort of, for example, for the city of Houston, you can, for example, the city authorities in the city of Houston can say, okay, the cost of climate change to our city was an X amount of dollars. Actually, in some other paper, we calculate that to be about $60 billion. And then they can say, okay, who is to blame for climate change? They're liable for $60 billion. Okay? And we can potentially sue RWE, which is a German electricity company that was calculated to be responsible for about 0.1% of global emissions in the past 150 years. Okay? Now, 0.1% is not a very impressive percent, but a 0.1% of a very large number is still a large number. So 0.1% of $60 billion is still $600 million. So RWE is liable for the city of Houston for $600 million of damages. That's enough money to feed quite a few lawyers for a lot of time. Potentially, you can already see how this kind of rationale can sort of translate into meaningful policy or processes and so on. We are working on another paper, and that is because we are linking basically emissions to the cost of climate change. We know, and we have a lot of models that estimate or try to quantify how much each of us is responsible in terms of our emissions, right? According to where we live, which country we live, what's our income, how far we live from work, what kind of work we do. All of these parameters will have an impact. How big is our house, and so forth. All of these parameters have an impact on how much emissions we produce. So with using that kind of exercise, I can actually tell John that John is specifically responsible for a certain amount of dollars damage that was incurred by the Nelson floods some time ago, right? Because we can do that whole tracing of causality. John is responsible because, he's a wealthy lawyer. Sorry, he's a law professor. He's not a lawyer. Apologies. But John has, according to where he lives and so on and so forth, we can quantify how much emissions he has been producing over his lifetime. Well, it's an estimate. We don't exactly know where he. Big Brother is not that active, and we don't exactly know where he is. But we have quite a lot of information. We can actually try and, for example, in New Zealand, because we have access to the IDI, the integrated data infrastructure, we can identify each person in New Zealand, sort of estimate how much emissions they're producing, and therefore what is their liability in terms of costs to New Zealand or costs globally in terms of climate change. And that's a project we're working on right now. And I'm going to stop there and happy to answer questions if there are any. I don't see anything. I see my slides.
Ilan, I'll start.
Yeah.
Is there, in your analysis of percentiles, of the population, was there a correlation for renters versus owners, and were renters more vulnerable population, underinsured, undercovered in their ability to deal with? I take that observation from the SLIPS events we just had here in Wellington recently, where the number of people we had to help from a civil defence perspective was way disproportionate. We had to help out a lot more renters and tenants rather than homeowners.
That's a good question. We haven't looked at that in the US case, the Houston case. I don't think the data exists, but I'm not completely sure. But I know that we haven't looked at that. There's definitely, if you've looked at my sort of numbers on Hispanics, you could question whether Hispanics are just poorer and that's why they're more exposed. But it's not the case normally there, right? So it's not the poverty, it's the ethnic identity that somehow is related to this. We're not sure how. So we're not sure why. Is it because Hispanics are late comers into the two population of Hispanics in Houston? One that were there before the gringos came, and one that sort of is more recent immigrants from Mexico. And we think that it's the latter group that's more exposed, although we haven't quite pinned down the evidence on that. With renters, we haven't looked at that at all. The data is more difficult, especially in the US case. I think here it's probably easier because you could actually get a lot of rental data from the tenancy board because they keep the bonds for each rental. So you actually can know exactly which houses are being rented and which houses are not. So potentially you could identify that here, but we haven't done that research here. We are hoping to do something similar to the stuff we've done in Houston for the city of Westport, given what they have experienced in the past couple of years, but haven't quite finished doing that yet. Other questions? Yeah.
Hello. Ilan, thanks for a really fascinating presentation. I have a bit of a curly question, so apologies up front. I understand very little about economics, but enough to know that it's
me also.
Complicated, right?
Yeah.
It's more of an art than an exact science.
Yes.
So I'm...
Even science is more of an art than exact science, but let's not argue about that, yeah.
My question, and actually it's really pertinent to the point you just mentioned about your upcoming Westport study, is costs are experienced at multiple levels. So you have the household cost, the local authority cost, perhaps some regional costs, and also national costs here in New Zealand. How do you go about capturing all of that and putting it into one number that you can say, this is the cost of this event? Because you've also got response costs, for deploying people and feeding them and all of that sort of thing. And then you've got the damage costs and various other sort of intangible costs. It's a bit of a grey, muddy space, isn't it, to sort of pull all of that together? How do you do that?
You can't aggregate all of these. You need to look at the details and use the kind of cost that is pertinent to the question that you need to solve. So if it's from a policy perspective, the kind of policy that you're trying to evaluate or whatever it is. There isn't one kind of cost, as you pointed out. Even in terms of just damage to residential housing, we can look at the cost of the damage or the cost of repairing the damage, which might be very different things. So the cost of building a new house might be very different than the value of the old house that was destroyed. There actually might be quite a big difference there. So it depends what the question is. You can't aggregate all of these things. Some households are going to lose some income or lose property. This is two different things. Income is a flow measure. Property is a stock measure. We can't really add stocks and flows together. And then if it's a flow measure like income, how long does it persist? That loss. So for example, we have another paper that looks at, okay, what is the impact on flooding on New Zealand households in terms of income? We can show that there is decreased income among specific groups that lasts a year, basically. And we can quantify that. And we can look at gender differences. We can look at a lot of things. But that's only one part of the income. You know, there might be a different group of population that had damage to their house. Their job has not been affected, so their income hasn't been affected at all. But there is damage to their house, not all of it insured, so that means they need to cut on their spending on whatever else they spend on education, on health, on whatever else they spend on food, whatever. Right? So that's a completely different measure. So we need to sort of target the measure to what we're trying to solve. There's no one number. The numbers I wasn't always careful enough to exactly define what I'm measuring here, but $143 billion, that's the damage as assessed by MDAT, the stock damage to assets. So property, private property, public property, infrastructure, and things like that. Doesn't look at decline in income or anything like that. We see, so I think that's as far as I can go with that. There is no number. Fine with me, yeah.
I'll just shout, it's all right. So given what you've just described, it's really complicated and you kind of need to figure out what the question is you're going to ask. What's your process for determining what the interesting questions are from a given event?
First of all, it's not that complicated. It's not rocket science. Economics is not rocket science. So, you know, I can explain it, you know, my proverbial mother, my actual mother, and who has no interest in numbers at all. She's a humanist. But my process, I'm a researcher, right? Thank God I'm not a policymaker. I don't need to decide on anything. And the question I ask is the question I can answer with the data that I have. So my process is to look for data and then identify the questions I can identify with that data. But I have the luxury of doing that because I don't have to resolve any policy questions. Yeah.
Thank you.
Yes. Yeah. Would you have suggestions to make financial protection more equal and target the most vulnerable? Definitely. I even had a suggestion in terms of the EQC. So the EQC right now, the way it's structured, it takes the same premiums for everyone, right? So every single homeowner here pays exactly the same amount of money to the EQC. I think that's wrong because if you have a very nice house and there is an earthquake, you're going to get paid more by the EQC than if you don't have a very nice house, if your house is much smaller or less sort of fancy. Okay? That, to me, means that we need to charge more from the people who have nice houses than we charge from the people who have small, tiny houses. But we're charging exactly the same from everyone. I don't think that makes any sense. And I've tried to argue for that. Of course, politically, it's a bit more difficult and to justify because it's kind of it seems equitable if you charge everyone the same, right? So we have a sense that it's equitable, but it's not. So do we need to account for these inequalities in shaping our policies? That's exactly the motivation for asking those kind of questions. Yes, of course we do. And you know, this is true in the US case, although I'm less knowledgeable about the kind of policies that they have, the FEMA has, but it's definitely true in our case. Yeah. The other question, given the hurricane classification is based on wind speed, is there a discussion to incorporate rain intensity to inform thresholds that inform hurricane classification? I'm an economist, I'm sorry. I have no idea who decides on these things. I do know that the classification doesn't make any sense from an economic perspective, also from a socioeconomic perspective, a sociologist or whatever you are who are interested in people. If you're interested in people, that classification system does not make any sense. And we have plenty of evidence that the cost of hurricanes is from the water, not from the wind. This is true in New Zealand, where we don't have hurricanes. We have actually ex-tropical cyclones. So I was told recently that there is a difference between extratropical cyclones and ex-tropical cyclones, which I'm not going to get into. But the storms we have here, the damage is from the rain. It's not from the wind. That's true in the Philippines. We have a project on the Philippines that shows exactly the same thing. It's the rain. It's not the wind. It's also the storm surge. And the storm surge does have some wind component. But actually, the main issue of the storm surge, the two issues, the two parameters that have an impact on the storm surge is the tide. When is the tide? Does the tide correlate with when the storm is hitting, making landfall? And how slow the eye of the storm is moving. That's not the wind speed. We are not classifying events by how quickly the storm moves. We are classifying them by the wind speed it generates. But actually, the slower the storm, the more damaging it is, because it generates more storm surges and it generates more rain. Right? The slower moving storms generate more rain because they just stand on a piece of a place and stay there longer. So they drop more rain there. So that's much more important, how fast the storm moves rather than the wind speed. But we're classifying it by wind speed. I hope someone is thinking about this, but I don't, no idea if they are. Yeah. Other questions? Thank you very much. Thank you.
Thank you, Ilan. That was awesome. I don't mean to sound surprised when I say that, but it was. It was really awesome. So thank you so much, Ilan, for that contribution and for that presentation. Now, we've got a bit of planning logistics to move through to the next plenary, so I want to make sure I get this right. So our next plenary session is in here on Dynamic Pathways Planning for Climate Change. That's with Nikki, so Nikki will be in here. And next door will be Jackie with Community-Based Emergency Welfare with a Psychosocial Support Lens. Now, I think this one's just about to finish, so what I might do, Nico, if it's okay, and with your indulgence, if you want to just take 5 to have a stand up, maybe have a bit of a walk around, if that's okay. If you need to use the conveniences, then by all means, as the Spirit guides, we'll look to kick off just before 12 o'clock, back in here, so maybe 5 to 12. Make your way back in. If you want to have a little bit of a break, have a walk around, have a stretch, that'll enable this one to finish off, and then we'll kick off just before 12 o'clock. Ka pai? All good. Thank you.